So Steve Davis is about to cue off at the start of this frame. What sort of opening shot do you think he'll make, Jack?
Well, that's a surprising question, Ted. He'll play the shot he always does, bouncing the white ball off a corner red, then off the back and side cushions so that it ends up safely on the bottom cushion.
Without potting anything?
Of course.
Sounds a bit unadventurous. Still, let's watch him do it.
Of course, Steve could have been less cautious in this game, as his opponent is hardly an expert. Peter Lawrenson is actually a sports scientist, and he intends to conduct a little research into the game.
Well, let's use a little bit of magic to reset the table. Let's stand clear.
It's Peter's belief that it is virtually impossible to pot a ball off the opening break.
Two.
Oh, no. Only two. So what happened to the other 13?
Well, let's remember that and see if we can do it again.
Well, that's two breaks you've had there, Steve, and the first one you potted two reds and none on this. But the balls are in completely different situations, aren't they?
That's right, and I did try and play exactly the same shot. And even with the first shot, even though I potted two balls, I wasn't on a colour properly, and I would have had to have played safe, so there was no real advantage.
Well, it may help us to understand why the shots are so inconsistent if we use the slow motion camera and some specially marked snooker balls. Can we have the camera, please?
Right.
This camera uses a lot of film, so we have to have very specific timing. Ready, 3, 2, cue, 1, go. And the ball's on its way now.
Right.
So obviously, it's going to hit that second red there.
Second red.
How do you think the rest of the reds will react? Where will they go? Which one's going to move first?
Well, I think if you follow the two lines down, the triangles, it seems to me that these two perhaps will get the most shunting.
Do you think they'll move off the quickest then?
Yeah, I should think this one will move off the quickest because it's got the least things in the way afterwards. Not too sure about the balls on this side. I think this one must move off very quick as well. And probably the second red there will move just as quick as this one.
You'd expect the reds to move first that are in the direct line of the contact with this ball, i.e. that one, and that one, would you?
Yes, probably, I suppose so, yeah.
How about the white ball? What will happen to that?
The white ball will bounce off and won't touch any more reds again.
And what do you think will happen to the pink? Anything at all?
If the shots hit hard enough, sometimes the pink does go up the table towards the blue, which is amazing, really. You wouldn't think so at all.
OK, let's move the white ball on and see what happens. And hold it there, please. Right, as you correctly predicted, that red has moved out, and also this one and this one. But what about the rest? What do you think?
Well, just generally going on. I think if we move on a few more frames, we might see which one's going to go the fastest. Between this one here and that one over there.
Yes, they are moving the fastest, aren't they?
That one, I think, has got some side on it now. The one we hit originally.
Yes, it's interesting to see which of the reds rotate. Why do you think that is rotating?
Well, I don't know. You can't really put a lot of side on a shot when you just hit a normal ball onto another one. But perhaps it's because it's hitting other balls very quickly.
OK, let's move the white ball all the way through, please.
Yeah, that ball's got a lot of side on it. And a couple of the other balls seem to be twisting just a little bit.
And of course, all the reds now moving off in their own directions.
Doing what they want.
I think it just goes to show how exceedingly complicated the break is, and I certainly wouldn't like to try and predict it mathematically. It only needs the triangle to be slightly askew, and the reds could go anywhere. And I think it just shows that you're absolutely right in deciding to play the safety shot from the break rather than try and pot the reds.
Very nice of you to say so.
Well, good. Let's go back to the game.
Right. Nice shot.
Well, the players seem to have satisfied themselves with the complexities of the opening break, yet there should still be a lot to investigate in the remainder of the game.
For impacts like that one, Jack, I would have thought the mathematics would be easier to understand.
That's true, Ted. Nevertheless, it is possible, you know, that Steve could still profit from a little more research.
Oh.
Everybody's seen one of these before. It's one of those adult toys that are supposed to calm the senses. It clearly demonstrates that if you have an object that hits an identical stationary object, the momentum is transferred to the second ball and the first ball remains stationary.
Hold on a minute. Why doesn't that happen when I play a normal shot on the snooker table?
Well, it does, Steve. Would you like to care to play onto this specially marked red ball? And play this cue ball onto it. And we'll use the slow motion camera to see what happens. Right, can we run that again in even slower motion, please?
Seems like the black ball was spinning and also jumping.
That's right, in it comes now. And the first thing to point out is that the red ball moves away at the same speed in which the cue ball comes in, which effectively is exactly the same as the Newton's cradle we've just seen. Now then, the cue ball itself is rotating, and in fact it jumps up and down in the air, doesn't it? Bounces. And then, while it's in the air, obviously no reaction with the cloth is possible. When it comes back onto the cloth, the rotation of the cue ball then reacts with the cloth and takes the ball on.
So it's really the spinning that's taking the ball forward, not really the fact that you're hitting it hard.
Yes, if the cue ball wasn't spinning, the ball would stay exactly where it was in shot instead of rolling out as it is now.
Yeah, that's what we call a stun shot.
Oh, yes.
Oh, shall I try that too?
Yes, let's go and try that.
Stun shot.
In fact, the stun shot, is it a much used shot by the professionals?
Yes, because I mean you can guarantee where the white ball's going to end up because it's just going to stop dead. And as long as it's still quite difficult to do. And that was a stun shot. Let's go back to the game.
That's given you one or two options, Steve. Which shot will you be taking now?
Well, you're playing quite a cagey game so far. You haven't left me that much, but I've got the chance of a red into the corner pocket, and if I play a run-through shot with the white ball, sending the white ball forward, I'll then
get on that black.
Chance to get on the black, so quite a difficult shot there.
Naturally, where the white ball ends up is controlled by the spin put on it, and Steve is an expert at that.
What I've got to do now, obviously, I take the pot for granted here, as most professionals do with any pot. It's just the positioning afterwards. And with this black, I've got to look for a ball, a red ball that is nice and easy to pot afterwards. And then really, they're all spread about all over the place. I shouldn't have too much difficulty. But I can play quite an interesting shot here. If I play the black ball and hit it fairly full in the face with some top on the ball, and by top I mean that the ball is hit above centre, so it spins faster than if it were just rolling, which makes it rotate that way. And so that when the white ball does then hit the cushion, even though it will be coming towards us, the spin on the ball will mean it starts going forward again. It's a bit like when you go with a ping pong ball, you send it away and then comes back again. And just means a lot of top on the white ball, and hopefully I'll send the white ball in a bit of an arc round into the position to pot this red ball.
Show me what you mean.
Right.
Did you manage to do that?
Yeah, that was the top going into the cushion and then becoming backspin off the cushion. And it just sort of makes a complete swerve, which is very much like a shot that the old billiard players used to play. If we just use the balls and move them about a bit. You'd say I was snookered on the black ball like that.
And you can actually pop the black with the red in the way.
The black without using a cushion. I'd just put a lot of backspin on. But because I can't get underneath because the cushion's in the way, I have to hit down on the ball like this. And I can actually make the white ball go in a curve. It's called a masse shot.
See that then? Oh, 7 away.
Right, so back to the games.
Right.
8 points. Now this is a shot, simple pot to pot the red ball in the corner pocket. But if I played the shot normally with topspin or with middle, which usually sends the white ball slightly forward, I wouldn't be in a nice position to pot the black. The white ball might go through to the cushion. So I want to stop the forward movement of the white ball, which means a stun shot, or in this case just a slight screw. And I do that by hitting the white ball on the bottom, which gives it backspin. And after potting the red ball, the white ball doesn't go forward. It comes back on itself, as if it was on a bit of elastic. Although I'm not going to hit this too hard because I just want to keep on the black.
Of course, if the cue ball is skidding across the cloth, then having top spin or bottom spin will make the cue ball go faster or slower, won't it?
That's right, especially in the case of the drag shot, which most of the professionals play to their advantage. And I think perhaps all the shots we play, or most of the hard shots we play, the ball start off by skidding in one direction or another, whether it be side or backspin. Now, if I wanted to pot the red ball in the top corner pocket, keep on the black, I could do it two ways. Firstly, I could roll the ball gently towards the red and pot it, but of course the table might roll the ball off course. So I can play a drag shot, which means I can hit the ball much harder by hitting it on the bottom and still achieve the same effect in the position.
That's strange, because the cue ball you would expect to change from backward spin to forward spin over a distance on the table, but it seems to happen instantaneously at one point.
That's right, and it's just like playing the shot from there instead of from here.
That's right. Could we see it again?
Yeah, sure.
Yes, it's the same again. But I think it's fairly easily explainable, Steve. This machine represents the action of the ball on the cloth. This is a spring balance which will show the frictional force of the ball against the table as the ball's moving over. As I start to turn the wheel, you can see that this red indicator shows that there's a frictional force as the ball is skidding across the table. Now, as I increase the speed, which means that the ball is skidding harder, the frictional force doesn't vary. It stays the same. When I stop the machine, this is when the ball is pure rolling and there's no frictional force at all. Now, if you relate this to what happened on the table, when the ball is skidding, the frictional force is in operation and then it's taken off instantaneously. And that's why the ball appears to change from backward spin to forward spin instantaneously on the table.
Oh, I see. Well, there's one thing that's always puzzled me, though, if you could come round here. If I strike the white ball with left-hand side towards the top end of the table, the white ball goes to the left. But if I play the same shot with left-hand side from the other end of the table, you'd think the same thing would happen. But actually the opposite happens, it goes to the right. Now, how do you explain that?
Could you show us again?
Right, if I play a shot up the table with left-hand side towards the black spot, the ball goes with the side to the left. Now, if I play the same shot with left-hand side down the table, you would think the ball would go to the left again, but it actually goes to the right.
Not so easy, that, Steve. If we accept that the table isn't on a slant, or that there isn't a magnet in the ball, then it must be something to do with the cloth, because that's the only thing that differs. The cloth is a little like a cat's fur with the hairs all pointing in the same direction. Just try stroking a cat the wrong way. Of course, the cloth's hairs are considerably shorter. One of the regular jobs which you have to perform maintaining a snooker table is to iron it, always in one direction, so the nap is always laid facing up the table. One has only to feel with one's fingers to realise that the table is far smoother with the nap than against it.
Yeah, I think most snooker players have realised that.
I think then we have to look at the point of contact of the ball and the cloth, and I seem to remember that there's a recent textbook that has dealt with the effect of spin on the ball and the contact with the nap.
Oh, so it has been researched.
Yes, not a lot though. In fact, this is one of the most recent books on the subject. This book was written in 1899. Not totally up to date, but if everything in here is true, then the problem shouldn't be too difficult to understand. In this diagram, the ball is travelling left to right, and that is also the direction of the cloth's nap. In other words, each fibre points to the right. As the ball travels, there is a greater area of contact at the front than there is at the back. So the spin causes friction at the front, in this case pushing the ball out of the paper, but very little at the back to counteract that force, so the ball curves. If the nap were reversed, the main force would now be at the back of the ball, not at the front, so the ball would curve the opposite way.
So you think it's as simple as that?
It sounds reasonable to me.
Have you got 10 pence?
Sure.
Let's see if this agrees with what the book says. I'm going to try and roll the 10 pence piece up the table in the line of the nap. And as you can see, whichever way it starts to curve, it continues that way. Now, could you roll a 10 pence piece back against the nap?
Like this, Steve.
Now, this time it did an S. Is that what you expected?
No, it isn't. I think it must be something to do with the fact that when you roll coins across a table, they'll always go towards you down the nap. Watch this. Even coins like that which start up the table always come towards you. In fact, it's a very good way to win a bet. I'll call heads. I think we must look closer at the coin rolling over the cloth. Here the fibres of the nap are pointing to the right, so if we look at the right-hand side of the coin, the explanation will start to appear. The individual threads are acting as little springs, each pushing the coin over. It's not much, but clearly it's enough. And while we're looking in close-up, let's see if the antique book had it right for the curving of the ball. Again, the fibres are pointing to the right. Now that's the maximum height of contact at the back of the ball. We're looking for a greater height of contact at the front. And there it is, that much. So they had it right in 1899.
Right, well, I've got 32, so I think I better declare, let you have a chance here.
Thank you.
What do you think about that?
Problem is, I always have problems with the long shots.
Well, if you're going for the black from there, it would be a very, very difficult shot. I tend to, in practice a lot of long shots, especially a long straight shot. And I usually line all the 21 balls up in a line along from the middle pockets and lining up the white ball straight with every ball, try and pop them into the top corner pockets from different positions. And I play a little game with myself, really, as a practice method, and try and get at least 11 of the 21 in.
Well, Steve, if a top-class player like you can only get 50% of long pots, then that goes to prove the difficulty. And Professor George Mackey of Edinburgh University has used his computer to help study this.
Right, I'll have a word with him. Well, George, how do you set up a computer to judge the comparative difficulties of pots on a snooker table?
Well, let me show you. If you're potting a coloured ball, it doesn't have to go into the very centre of the pocket. There is an angular variation it can make, which would still enable it to go in. But anything more than that angle, and it would miss altogether.
Right.
What the computer does is calculate the angular tolerance in the white ball, which would enable the black ball to go in.
Right.
And that measures the difficulty of the pot. The smaller the angle, the more difficult the pot. I've tried to simplify things by getting what I call a difficulty factor. And that I estimate by setting up a pot which occurs very frequently in snooker, particularly at the professional level. The straight pot of the black from there. And that I call a pot with difficulty factor 1. A pot with difficulty factor 2 would be twice as difficult because the angular error you can make in that case is only half the angular error you can make in this case.
But what about the situation that Peter finds himself in?
Yes, well, let's set that one up then. That's that pot there.
Right.
Well, that has got difficulty factor 10.2. It's about 10 times as difficult as the standard pot is.
Okay. What do you think the purpose of this is?
Well, I think it's interesting to be able to give a number to associate with the difficulty of any given pot. I would hope the television commentators might be interested in explaining this to the viewing audience. But there's another application which makes use of some ideas in statistics. It enables you to tell the frequency with which you might be able to succeed with any given pot if you know the frequency with which you would be able to execute the standard pot.
Right.
For example, would you like to know your chance
Yes,
of
go
getting
on.
that?
How many times
half
out of
pot?
10?
Well, for somebody like Peter, who might be able to execute the standard pot, say 9 times out of 10, probability 0.9, his probability of getting the more difficult pot is 0.13, which means you get it about once in 8 times. If you could pot the standard pot 99 times out of 100, then the probability is 0.2, which means you'd get the more difficult pot about once in every 5 occasions.
Right.
But even someone like you, Steve, who could probably get the standard pot 999 times out of 1,000,
If I could stay awake.
your probability of success with the difficult pot is just 0.26, which means about only once in 4 occasions would you get the more difficult pot.
So I'd still be right to blow the safety shot. 1 in 4 is not good enough.
I'm sure you would, yes.
Thank you. Very nice.
Okay, Steve, back to the game.
Oh, good shot. 13. Now there's a difficult, an interesting situation. Comes up quite a lot in snooker, especially when there's lots of reds on the table. They've only got 2 left. Both the balls are lined up for the pocket. So really it's quite a simple shot, and plenty of people could do it, and then after you potted that blue, should be no trouble. Just to hit the second red, onto the first red.
And then it'll go straight in.
Go in. It's normally said that if you draw a line through the centres of these 2 balls and aim at the back one, the front one will follow the line no matter where you hit it from. And of course, knowing this helps me to play trick shots. Watch this. Another question answered.
So I shouldn't have any trouble potting this, then?
Let's hope not.
Right. Oh, dear.
14. Oh, it's not bad. Perfectly on the blue.
Oh, dear.
Now, you see, you had better shot with the other ball. What you should be able to do, really, for any sort of pot, is where it doesn't matter where it is. Take it around here. Is to actually imagine another white ball in line with the blue, the same as the 2-ball set we've just had. And if you could,
the same way the 2 reds were?
that's right. And if you could actually imagine where the white ball will appear, then you should pot the ball. So it's just a case of
I see.
getting down on the shot, imagining where the white ball would be, and that works every time. Perhaps I should have told you earlier, but that's my edge.
Well, it's the end of my break with 14 to go on.
Right. Well, I'm on the red, and as you can see, just a case of lining up on the imaginary white. And once again, the red ball should go in.
Show me how to do it again, then.
Right.
right down the middle.
Right, now, nice position for the blue.
So science has explained everything so far, Steve. Is there any other aspect of the game that you think science can help us with?
Well, I hope so. I can play a shot and play it perfectly, but sometimes the balls they don't go in the pocket, and it's not my fault. I feel it's the sound of the balls is different.
Oh, isn't that what's called a kick? It's caused by chalk, isn't it?
Well, yeah, it's called a kick. We don't really know what it's called. So some players think it's by chalk. I think it might be by static electricity. But if you remember in the 1981 semi-final against Cliff Thorburn, I was 6-all, down in the 13th, and I was on a good break, and all of a sudden this happened.
Well, I think I detected a slight kick there from that contact. Yes, the referee is cleaning the ball. I thought there was a nasty sounding contact there.
You look pretty upset there, Steve.
Yes, I was. I felt I hadn't played the shot at all badly and got punished for it with a kick. And as you see, Cliff Thorburn asked Lengani, the referee, to clean the balls, to take all the chalk off. But I'm not too sure that's really the reason for kicks. Perhaps it's due to static electricity. And in cleaning the balls, the referee might be putting more static on.
Well, this looks like something I can investigate, Steve, and perhaps we ought to start by the sound of the contact of the two balls. Now, in the semi-final itself, both you and Cliff Thorburn and the commentator were able to detect that there was a different sound on that kick.
That's right. Yeah.
Yes, but we didn't hear it in the studio, and that's probably because the sound didn't come through the microphone.
Right.
So what we'll do now is we'll put the microphone next to the red ball, and if you can play the cue ball into the red ball, we'll see what the normal sound sounds like.
That was a good contact.
Good. Now what we will do, we'll try and put some static charge into the cue ball here and do the whole thing again. Perhaps you ought to take the chalk off the end of your cue, so
Okay.
there's no chalk at all on the ball. Now touch it onto a gold leaf electroscope. Yes, statically charged. I'd like you to pop the red ball and we'll see if there's any difference.
No, not at all.
That's a normal sound again?
Yeah, perfect.
Right, now then, we'll take a red ball and put some chalk on here, because that way you'll be absolutely certain that the chalk will contact as the two balls
Right, okay.
hit each other. So there's chalk on the red ball there, and we'll put that down there. And if you can then hit the cue ball onto the red ball, we'll see if there's any difference there.
Oh, yeah.
There's a definite sound difference there.
That's right, it was a kick.
Well, of course, that's not conclusive evidence, but it does seem as if it may be the answer to finding out what causes a kick.
Right, back to the game.
Let's carry on then. Should be no problem finishing these off then, Steve.
Well, I hope not. Right.